and welcome to my channel. In this video, we're going to be talking about chemical reactions and types of chemical reactions. To start, what is a chemical reaction? A chemical reaction is the process of converting one or more substances, which we usually call reactants, into one or more new substances called products. Types of chemical reactions. The first type is called synthesis or combination reaction. And from the word combination, it just means adding things together, okay? So when you add two or more things together and they give you one single product, that is what we call combination reaction. And for example, if you have hydrogen combined with iodine, and this gives us hydrogen iodide. This here is called synthesis. So these two things combined together and they gave us one single product. Again, you also have H2 hydrogen again plus oxygen, and both of them gives you H2O. One single product. So the best way to identify synthesis or combination reaction is that you may be adding two or more things. It might be more, but the product would be one compound or molecule, just one product, just one product. So that is how you tell that you have a synthesis or combination reaction. The second type of chemical reaction is called decomposition. So it is the opposite to synthesis or combination reaction. So for example, if we have the product we formed in the last example, if we have that giving you back hydrogen and iodine, so you see it's the opposite of synthesis. So a larger compound breaks down into simple ones, two or more simple ones. It has to be more than one. Okay, two or more simple ones. So you also see H2O, when it breaks down into hydrogen and oxygen, this is decomposition. Okay, so you're breaking down a large molecule into simple ones. That is what we call decomposition reaction. And the third example or type of chemical reaction is called the single replacement or displacement reaction. Now, before we talk about this, I want to talk about the reactivity series. When we say reactivity series, single replacement reaction, you need to understand the reactivity of metals or halogens in order for you to be able to know if the reaction will proceed or not. Not all single replacement reaction can proceed or can form a product, depending on the type of elements displaced or replaced. So let's say, for example, we have potassium plus sodium chloride. This is a typical single replacement. Now note, this is an element and it combines with a compound. It's going to be giving you a new element and a new compound. So that is one way to know that you are dealing with single replacement reaction. Now this potassium has a positive charge. It's in group 1 of the periodic table and has a valence electron of 1, which means that it can easily give off that electron and gain a positive charge of 1. So it has a positive 1 charge. Usually we don't write the 1 out, so we just say K+. Sodium in this case also belongs to group 1 and will have a plus charge. Chlorine is in group 7 of the periodic table, which means that it has a negative 1 charge. Okay, so it requires 1 electron to make up its octet, and therefore it will have a negative 1 charge. Now, in chemistry, we say that like charges repel each other, while unlike charges attract. So what this means is that potassium is going to go attach itself to the negative charge, okay? It's going to combine with the negative. Now, when it does that, it replaces the sodium or displace the sodium, and that is why we call it a displacement or replacement reaction. It is single because it is only one thing that is being displaced or replaced, which is the sodium. So when this combines, you're going to then have KCl on this side, okay? And sodium has been displaced or replaced. So it stands on its own. So this is why we call it a single replacement reaction. Now, why I say that you need the knowledge of reactivity series is because this replacement can only happen if potassium is more reactive than sodium. So if potassium is not more reactive than sodium, it will not be able to replace or displace it. So what it's trying to say is K has to be stronger in order to kick sodium out. Looking at the reactivity series, I'm just going to write out a little bit of it. Potassium tends to be on the very top, okay? So you have potassium on top, followed by sodium. So yes, potassium is able to kick sodium out. It's actually above sodium in the reactivity series. But if you had a situation whereby, for example, you had this to have been calcium plus probably potassium chloride, this will lead to no reaction, okay? And there are possibilities that you may come across this or have come across this type of questions whereby the answer to the question will be no reaction because calcium is less reactive than potassium and therefore won't be able to kick potassium out. It's not possible. So that is what this is all about, okay? So whenever you see a reaction that has an element and a compound, and then on the product side, you see a new compound and an element, a new element being formed, know that that is a single replacement reaction. And if you're asked to write the product, you would have to ensure that the elements that you are trying to kick out is actually less reactive than whatever it's replacing it. Okay, so for example, you have to make sure that potassium that is kicking the sodium out is more reactive than sodium before you can proceed with the reaction. If that is not the case, then there won't be any reaction taking place. Okay, now that leads us to the fourth type of chemical reaction, which is called double replacement or displacement reaction. Now, in double replacement reaction, you would have two compounds combined and giving you two new compounds. So two compounds combines and gives you two new compounds. So for example, if we have KCl plus H2O, this is a double replacement reaction. Now, again, in order to figure out what the products are, we're not actually talking about writing of reactions at the moment, but just so you have an idea, you need to actually know the charges on each group in this compound. So potassium here belongs to group 1 and will have a positive 1 charge. Chlorine would have a negative 1 charge. And in water molecule, we have H plus and OH minus. These are the ions that make up H2O, okay? So the positive sign, of course, we combine with the negative of the opposite side, okay? And as such, it displaces or replaces the hydrogen. So the first step here, you have the KOH, okay? And then the hydrogen here is going to then replace the potassium, combines with this Cl and becomes HCl. So you see, that is double. There is a double replacement going on. This is why we call it double replacement. K replaces hydrogen on the other side, and hydrogen replaces K on the other side. So you have double replacement or displacement going on. And that is why it has that name. Okay, so the best way to tell if you have a double replacement is to look at your reactants and your product. If you have two reactants, compounds, okay, two compounds, and they are giving you two new compounds, you can see over here you have a different thing, then that tells you have a double replacement. Now, under double replacement, we also have another type of reaction, which is called neutralization reaction. Now, this is specific for acid and base, okay, HCl and sodium hydroxide. Now, when acid reacts with a base and it gives you salt and water, we call that neutralization reaction. Neutralization reaction is also a double replacement reaction, okay? So in this case, we have a positive on the hydrogen, we have a negative one on the chlorine, positive on the sodium, a negative on the hydroxide, and of course, the hydrogen is going to go combine with the OH, and that gives you H2O, okay? While the sodium combines with the chlorine and gives you sodium chloride. So this is what we mean by salt and water. Okay, so that's how you tell if you have a neutralization reaction. So that is also a double replacement reaction. The hydrogen replaces sodium on this side, or on the right-hand side, and the sodium replaces hydrogen on the left. So what I mean is this combines with this, replaces the hydrogen, while this combines with that, replaces the sodium. Okay, so that is double replacement reaction. Now, on combustion, the first thing that should come to mind whenever you hear the word combust is oxygen. Oxygen is and must be part of the reactant. Okay, it means burning, and when you do burning, there is oxygen present. So if you combine, for example, methane, which is CH4, if this combines with oxygen, it's going to give you carbon dioxide. So combustion gives you the oxide of the compound you're burning. Okay, so carbon dioxide, you have methane here, it gives you carbon dioxide and then gives you water. So these are the two products. Now, this is going to be the same irrespective of what you are reacting, how many carbons, okay, that you are reacting with. It's going to give you carbon dioxide and water. So what am I trying to say? Even if we make use of C6H6 plus O2, you see this is 6 carbons, this is benzene, it's still going to give you carbon dioxide and water. So this is not balanced. I'm just going to quickly, we're not talking about balancing of equation now. So I wouldn't waste your time talking about that for now. So, okay. So this is the balanced equation. This is complete combustion. There is what we call incomplete combustion. And the difference would be if methane, which is the first one we use, undergoes incomplete combustion, it means that the right amount of oxygen was not used. Okay, so you're going to have carbon monoxide instead of carbon dioxide. That's the only difference. Every other thing would be the same, but you would have carbon monoxide instead of carbon dioxide. So in this case, it's not it wasn't complete. So complete combustion would give you carbon dioxide, while incomplete would give you carbon monoxide. Okay.